Good evening, everyone. My name is Edwin Rondon, and my partner's name is Quizal.
Hi everyone.
And tonight, our presentation topic is about characterizing private clouds, a large-scale empirical analysis of enterprise clusters. Before we begin with our presentation, I wanted to provide a brief description of private cloud services. Private cloud computing delivers service to a single organization as opposed to public cloud, which serves many, provides direct control of infrastructure and data. Private clouds carry management and maintenance costs. Introduction. On-premise clusters are gaining popularity due to better security, regulatory constraint, and enhanced quality service, but there is a lack of research made on enterprise clusters as opposed to public and consumer systems. Research has been conducted on consumer equipment and public cloud systems, but up to now, not much indicative research has been done on enterprise and closed equipment. In order to have a better understanding of private cloud, we take a closer look by examining hardware reliability, storage measurements, compute measurements, hardware failures, cluster growth, and data source of enterprise clusters based research conducted on Nutanix broad customer base. Nutanix is a corporation which business is to provide enterprise cluster service to customers within each line of business. The article is focused on the trade-offs between consumer, public, and private hardware reliability cloud systems. While there have been many studies on public and consumer-grade hardware, the result cannot necessarily be translated to private cloud. Private cloud use enterprise-grade hardware, which has more reliability than consumer-grade. In addition, private cloud have long-running applications that may not be sustainable by public cloud, which instead have short-running applications. In this article, we will get into the details of the study conducted through graphs, charts, and formulas that provide powerful evidence and an in-depth look of the performance of cloud systems. Motivation. Extensive measurement study that provides us with an insight of the challenges and trade-offs of enterprise-grade equipment. Characterization of failed enterprise-grade hardware components, virtualization-related issues, as well as bugs and misconfiguration issues. The characterization of storage, compute, and I/O is taken into consideration to figure out how these needs vary over time. Durability is also taken into account in this characterization of private clouds. A machine learning approach is taken in order to help predict cluster growth. There have been many studies conducted in public and consumer-grade hardware, but it has not taken a deeper look, or it has left out data in other areas. For example, hardware reliability. When it comes to hardware reliability, a closer look is taken on hardware failure. Storage measurements. The target here as well is a closer look at enterprise application in different organizations within different lines of business where workload differ significantly. The data being analyzed are storage capacity, usage, and how they change over a period of time. Also, measurement for data transformation, compression, and dedupe are looked upon to figure out how it impacts storage capacity. Compute measurements. A fine-grained examination of workloads and application in private cloud is looked into closely. Design main idea. So measure methodology. Nutanix cluster architecture. We're going to be looking at these 3 points, which are Nutanix cluster architecture, data source, and the subcategory and data caveats. Nutanix cluster architecture. The data was gathered from installation at different enterprises, which can provide a glimpse on Nutanix private cloud characteristics. The data sources used in the study ranges from cluster instrumentation to customer maintenance trouble tickets. Nutanix clusters provide virtual execution applications which have embedded virtual machines that contain available storage that are accessible through file system interfaces. Data source. On the data source, we look at the subcategory metrics. We see that the database taken from customers clusters, which contain different timeframes of 60 seconds to per day basis. Data extracted from customers include CPU usage, I/O load, cluster configuration, and storage usage. On the customer end, data from customer accounts, clusters, configuration, hardware dispatches were taken into consideration for the study. On every occasion a hardware dispatch is created, a new log documenting event is entered into the database, and this applies for new customer contracts. For repair and maintenance, documented information regarding hardware component return rates. This includes the following: hard drives, solid-state drives, memory, and other metrics. This data is recorded on a daily basis. Here we can see some more information in regards to the data source and the subcategories. For example, we see here metrics. The study was conducted on these three categories, which are configuration, and we can look at the date right next to it, November to November 2014. We also see storage and IOPS and CPU. On the customer side, we see that they took information on the accounts, assets, and cases. And for repair maintenance, we see that we look at the date, and that's within those days they gathered the information for repair and maintenance. Data caveats. Data retrieve is related to failure of customers' data sources. Data on trouble tickets that are brought up on software and hardware issues. This information is not automated, but instead is entered by trusted human operator, accurately documenting information. Otherwise, there will be discrepancies on the data. Nutanix architecture virtual machines will automatically migrate to deal with unexpected resource load, migrate data across nodes to preserve locality and to achieve good load balance between each other, respond to temporary and long-term failure by replicating data to live nodes, which will maintain data integrity. The storage software and cluster management can provide clustered state and can be used to obtain reliable measurement data. Here, we're taking a look at the cluster profiles, and this provides a bit of information on the samples that were used for this study. The number of clusters used for the study were over 2,000 from different industries, including automobiles, healthcare, and financial institutions. These industries only represent a small portion of Nutanix cluster population where measurement data is collected. As you can see, the number of clusters were 2,168, and within those clusters, there were 13,394 nodes, and within those nodes, there were a range from 70,000 to 90,000 disks, and the cluster size ranged from 3 to 40 clusters, meaning units are computers, basically. The following are the cluster configuration. The image below you shows the different cluster configuration throughout the different industries. Configuration 1 refers to compute heavy nodes, at core 24 at 2.5 gigahertz. Configuration number 3 refers to storage heavy with 30 terabytes, and configuration 2 is more of a baseline version. As you can see on the charts on this table, it will show you give you more information on the hertz, and also as you can see on configuration 3 right here, 30 is storage heavy. And now I will introduce Rizal. He's going to be speaking about the failure analysis portion. Rizal?
Yeah, okay. So during the failure analysis study, they focus on the private cloud clusters, which build from the enterprise grade commodity components, which may fail and leading to those three problems. It is on availability, it is performance degradation, and data loss. So this provides a strong motivations to understand their characteristics. And then they analyze the failure data along various dimensions. And then like component return rates and time to repair and so on. So they provide the details on the two types of failures, which is hardware failures and virtualization failures. Next. So in this table, you can see those are all the hardware failures they collect. So in the table, you can see that less than 20% of the total hardware failures are due to the HDD problems. And then it followed by 16% of memory issues. And then the third and fourth is SSDs and the power supply unit. These are two components that make it to the top four. And you can see the top three HDD, memory, and SSD failures. Those combine around 50% of the total hardware failures. Next. So as they're doing the research on the hardware distribution, the author and their team found out some information may not be accurate because the hardware component manufacturer typically specify the reliability of their products by estimate probability that a component will fail during a full year of use. Because the customer use sometimes does not necessarily match the estimation. So in order to clarify this problem, they collect the data and reports from customers and made the annual return rate table, which shows on this page. Okay. So this table provides the ARRs for the four hardware components that account for more than 60% of the total hardware case. We can see these values are lower than the typical industry standard. For example, for the HDD, HDD replacement rates have been reported to be in the range of 2 to 9%. And for the SSDs, the range is from 4 to 10%. So there is one reason that can explain this. So during the study, the author and the group, they focus on studying enterprise-grade hardware component, which is a high-end portion of the commodity hardware. And for the other person, they studied the report numbers based on the consumer level commodity hardware, just like the HDDs. I think the other might also be better off because they're not being used. Like the others are not being used at the full capacity. So next. So here comes to another failure, which is a virtualization failure. So virtualization failure can refer to the configurations in hypervisors, and another is software bugs. So here's some configurations examples. So many customers attempt to implement resource pools in VMware, but mistakenly configure some parameters and experience problems in their clusters. And then some people try to migrate from standard to distributed virtual switch in VMware, and they incorrectly handle the configuration. So by the way, the VMware is an aggregated physical computer hardware, just like the CPU and memories, so which also allocated to the virtual machines. Next. Okay, so there's some the hypervisor. Then there comes the hypervisor software bugs. There's a problem during the research that they found out that once a customer experienced the repeated disconnection between the vCenter server and a centralized cluster management software and ESXi hypervisor running on the host. Because of the host daemon process crashing and restarting. And after that, they found out it's due to a software bug. So this issue was not a direct cause of data loss or other server issue, but it could have triggered them. So the team's suggestion during the study, they suggest by disabling a cluster health mechanism that periodically executes their command. So next. So in this figure, you can see clearly about the component of hardware and virtualization cases. So as you can see, around 60% are due to the hardware problem, and around the other 40% are due to the virtualization related issues. It is either hypervisor bugs or misconfigurations. And sometimes the virtualization failures can be as high as the hardware failures. Next. So most of the failures can be self-healed. They can resolved automatically, but some of them need to be fixed manually. So this figure shows the cumulative distribution function of virtualization and hardware cost cases time to repair. We can see like around 25% of hardware cases require at most 1 day to repair. And around 50% of hardware cases are closed in 3 days. As they usually involve the actual shipment. Next. So here's a summary of this research on the failure analysis. So the measurement data helps characterizing the failure rates of all components used in private enterprise clusters. And the hard drives failures, memories, SSDs, and the PSUs correspond to the bulk of the hardware failures. And then the failure rates of the enterprise-grade hard drives and SSDs are significantly lower than that of the consumer-grade equipment. And then the virtualization failures, which include software bugs and configuration errors of the virtualization software, constitute a significant fraction of the observed failures. Next. Then we goes to the implementation part. So here's a model this team and the other has created. So they build upon those measurements to answer some of the questions that are pertinent to the use and management of enterprise clusters. First, they provide an analytical model for durability based on the failure rates and storage characteristics. And then they provide a predictive model that intends to provide a better understanding of the reasons behind cluster growth in private settings. Next. So here is a analytical model. During creating the model, they assume that the replication factor used in cluster C is IF2. And IF2 means the data is stored in 2 locations. IF3 in 3 locations, IF4 in 4 locations, and so on. So assume that the replication is performed randomly. Then with IF2, every piece of data stored on nodes is replicated on one other random nodes in the clusters. So we can see the model. The delta T represents the time, the N represents the number of nodes, and the D is represent the storage usage of any nodes, and then R represent the rate of data transfer in the network. Okay, next one. So we can take the P delta T as a probability of a node's failure in delta T time. As Q, then we can get another model as Q equal to the data loss event, where a node's failure F1 occurs and a subsequent failure F2 happens within delta time of F1. So in this model, we can see the first term in the summation indicate that there are no failures in the interval, and the product in the second term has 2 components. The first refers to the probability that exactly 1 node failed in the given interval, and then the second indicates the remaining n-1 nodes do not fail. Hi, sorry guys, I just went offline, so I'll just restart explaining this table. So
Yes.
the first term in the summation indicate that there are no failures in the interval. The product in the second term has 2 components. The first refers to the probability that exactly 1 node failed in given interval. Then the second indicates that the remaining n-1 nodes do not fail within delta T of the first failure. So in order to characterize durability on a yearly basis, we need to consider all delta T intervals within 1 year. So we got another formula. So this formula is the probability of no data loss over 1 year period. As you can see, the capital N is a number of intervals of delta t times in a year. Okay, next page. So here goes a data loss in the private cloud. Then we now apply the model above to characterize the data loss in the private clouds. We use a following measurement observed in our clusters to perform the durability calculation, which is the failure rates, the I/O replication rate, and the use of storage capacity. So in this table, you can see that the probability of data loss over a period of 1 year for 60 of the clusters is less than 10 to the negative 6 for RF2, which it gives a durability of 6 nines or more. Instead, in the case of IF3, it is 9 nines durability or more. So next page. Then they found out that customers periodically add nodes to their existing clusters. So it would be interesting for them to understand what drives such growth. So they resort to the machine learning driven approach. So first, they frame this analysis as a binary classification problem, where the goal is to predict whether a cluster would increase its size or not. And then they use a linear classifier. More specifically, they train a logistic regression model because they are more concerned with the interpretability of the result rather than achieving high accuracy. For example, they use a subsample of clusters C to build a dataset D of n examples. For example, they considered around 200 clusters over a period of 8 months, which gave a total of 15K examples. Then this split into 17% training and 10% validation and 20% testing. Okay, so next. So in this figure, we can easily solve the construction of the 3 set of basic phasors, which is based on the general cluster size characteristics, which is FC, and based on storage related information, which is FS, and based on a performance matrix, which is FP. So they consider 2 main categories of models. The first one is the memory, and the second one is the memoryless. So next page. Then here comes the evolution and the result during this research. So the top 3 most important phasors of their best model together with their weights, as you can see in this figure, which is the nodes and HTD and VMS. See, they're only interested in the relative ordering of the phasor weights. The higher the weights, the more important the phasor. So the cluster size is one of the most important predictors of cluster growth. In this particular dataset, they observed that most of the upgrades are done from small-sized clusters. Thus, the high importance of this phasor. The chances that you increase the size of small-sized clusters is higher than if you already have big clusters. Then the HDD usage ratio is also a top phasor. On average, the HDD usage ratio is much lower in negative instances than in positive ones. And then they indicate that the growth decisions are also driven by an increase in storage demands. And then the number of VMs per nodes from a previous example of the clusters also contributes to the growth decision. On average, the number of VMs in negative example is lower than in positive one. And then according to their model, the third factor that drives clusters growth in private clouds is given by the need of more VMs. And then Edwin will do the conclusion.
All right. In conclusion, the adoption of on-premise enterprise clusters within companies is growing at a fast pace. Hardware failures are fewer with enterprise-grade hardware than with consumer-grade hardware, and notice a surprisingly low percentage of virtualization-related problems in comparison to consumer-grade. Private clouds tend to provision most of the resources upfront, and that the usage behavior observed is quite stable. The elasticity requirements in these clusters are not as essential as in public clouds. Build on these measurements and propose an analytical model of durability and predictive model for analyzing cluster growth. Finally, after the conducted studies, we have a better understanding of the challenges and trade-offs in regards to a private cloud system. This understanding serves as a guidance to enhance better design and apply proper management. Thank you everyone for watching our presentation.
Thank you, guys.
My name is Edwin and my partner's name is Wazal.
Yep.
Thank you and have a good night.
Good night.